the second speaker in this pre-coffee session, who is Professor Richard Dawkins. Perhaps he needs rather little by way of introduction, but I would like to say a very few words. I think just as Darwin changed the way we think about biology or thought about biology in the 19th and subsequent centuries, so Richard's writings, most notably The Selfish Gene and The Blind Watchmaker, had enormous impacts on the way we think about evolution in the 20th century. These books were universally regarded as classics. Of The Selfish Gene, the New York Times said, "This is the sort of science writing that makes the reader feel like a genius." I'm sure we all enjoy that feeling now and again, much to Richard's reward. Robert McKee referred to this book simply as a classic, and The Independent as a genuine cultural landmark of our time. Richard was elected Fellow of the Royal Society of Literature in 1997 and of the Royal Society in 2001. Until recently, he was Professor of the Public Understanding of Science in the University of Oxford. And I'll give you one last statistic, which he may or may not approve of. He was listed by Time magazine in 2007 as one of the 100 most influential people in the world. Richard.
Makes the reader feel like a genius can go two ways, I suppose. Are we going to have the slide up, please? Thank you. Was Darwin the most revolutionary scientist ever? Newton, Einstein, and the architects of quantum theory might have outclassed Darwin in sheer intellectual firepower. But Darwin probably did revolutionize the worldview of people outside science more comprehensively than any other scientist. He may be only one plausible candidate for the most important or most revolutionary scientist ever, but Darwin has a strong claim to be the most seditious. He was seditious because he destroyed an argument that must have seemed knocked down obvious to the pre-Darwinians, including the young Darwin himself, for the Reverend William Paley was compulsory reading for Darwin's cohort of Cambridge undergraduates. If it looks designed, it must be designed. And the more designed it looks, the stronger the argument. Darwin's dangerous idea, apologies to Dan Dennett, was seditious, revolutionary, deeply surprising. And yet, having eluded philosophers, scientists, mathematicians for millennia before him, it was an idea that came independently into the prepared minds of at least two naturalists in the 19th century, Darwin himself and Alfred Russel Wallace. Darwin and Wallace are not the only 19th century writers with claims to priority for the idea of natural selection. There's Patrick Matthew and Edward Blythe and one or two others. If those four claims are upheld, it should be a matter of some national pride that all four independent discoverers of natural selection were British. But should they be upheld? Edward Blythe's version is, I think, only what we today would call stabilizing selection. Natural selection preserving the original type, not natural selection driving evolutionary change to ever new types. No wonder Blythe was a staunch creationist. He thought of natural selection as preserving God's original creations in their pristine archetypal state. He was the very opposite of an evolutionist. Natural selection, in his formulation, would amount to a force of resistance against evolutionary change. Patrick Matthew came closer. He used his experience of growing apple and pear trees in his Scottish orchard to write a book in 1831 on naval timber and arboriculture. In the appendix to this work, Matthew recognized that the principles of artificial selection could be generalized to natural selection. Unlike Blythe, Matthew didn't see natural selection purely as a stabilizing force. He even went so far as to speculate that the progeny of the same parents, under great differences of circumstance, might in several generations even become distinct species, incapable of co-reproduction. When The Origin was first published, Matthew protested at Darwin's failure to cite him, and Darwin punctiliously did so in later editions. Darwin correctly said that Matthew clearly saw the full force of the principle of natural selection. And Matthew also clearly saw the importance of overproduction and the consequent struggle for existence. But I'm left wondering whether Matthew really grasped the immense power of the discovery that he'd made. Did he appreciate that natural selection is the answer to the great riddle of existence? Did he see it as the explanation for all of life, the destroyer of the argument from design? If he had, wouldn't he have published it in a more prominent place than the appendix to a manual on naval timber? Wouldn't he have trumpeted it from the rooftops as arguably the most important idea anyone ever had? On the contrary, Matthew seems to have found the idea so obvious, almost trivial, as to need no discovery. In a letter to the Gardener's Chronicle, he wrote, "To me, the conception of this law of nature came intuitively as a self-evident fact, almost without an effort of concentrated thought. Mr. Darwin here seems to have more merit in the discovery than I have had. To me, it did not appear a discovery. He seems to have worked it out by inductive reason, slowly and with due caution, to have made his way synthetically from fact to fact onwards. While with me it was by a general glance at the scheme of nature that I estimated this select production of species as an a priori recognizable fact, an axiom requiring only to be pointed out to be admitted by unprejudiced minds of sufficient grasp." With hindsight, we may be tempted to sympathize, but where Huxley, on closing The Origin, movingly said, "How extremely stupid of me not to have thought of that," Matthew's response would seem to have been the Victorian equivalent of, "Big deal, so what else is new?" Is this the response of a man who, 7 years before Darwin and 27 before Wallace, found himself in possession of the central, unifying idea that dominates all biology and explains almost everything about life? I agree with W.J. Dempster, Patrick Matthew's modern champion, that Matthew has been unkindly treated by history. But unlike Dempster, I hesitate to assign full priority to him. And the same could be said even more strongly, which is why I haven't treated him in detail, of W.C. Wells, whom Darwin also scrupulously acknowledged. Wells seems to have arrived at a form of group selection rather than true Darwinian natural selection, as Matthew did. Alfred Russel Wallace was different. Although he discovered natural selection later than Patrick Matthew and later than Darwin, of course, he has a genuine claim to be up there with Newton and Darwin among the immortals. When Wallace hit upon natural selection, he was in no doubt of its immense importance for the whole history of life. The very title of his paper, the one he sent to Darwin, which set the cat among Darwin's pigeons, says it all. On the tendency of varieties to depart indefinitely from the original type. Depart indefinitely, that was the key phrase. If they depart indefinitely from the original type, they can branch and eventually spawn all of life. And Wallace made that explicit. The drama of how Wallace's paper arrived at Down House on the 17th of June 1858, casting Darwin into an agony of indecision and worry, is too well known for me to rehearse it. In my view, the whole episode is one of the more creditable and agreeable in the history of scientific priority disputes, precisely because it wasn't a dispute, although it so easily could have become one. It was resolved amicably with heartwarming generosity on both sides, I think especially Wallace's. Wallace's 1858 paper hit Darwin like a lightning bolt. The similarity between their thinking was uncanny. Wallace even used the phrase struggle for existence, and he devoted a lot of attention to the exponential increase in numbers, which was another of Darwin's key points. Wallace wrote, The greater or less fecundity of an animal is often considered to be one of the chief causes of its abundance or scarcity. But a consideration of the facts will show us that it really has little or nothing to do with the matter. Even the least prolific of animals would increase rapidly if unchecked, whereas it is evident that the animal population of the globe must be stationary or perhaps decreasing. Wallace deduced from this that the numbers that die annually must be immense, and as the individual existence of each animal depends upon itself, those that die must be the weakest. And Wallace's peroration could have been Darwin himself writing. The powerful retractile talons of the falcon and the cat tribes have not been produced or increased by the volition of those animals. But among the different varieties which occurred in the earlier and less highly organized forms of these groups, those always survived longest which had the greatest facilities for seizing their prey. Neither did the giraffe acquire its long neck by desiring to reach the foliage of the more lofty shrubs and constantly stretching its neck for the purpose, but because any varieties which occurred among its antitypes with a longer neck than usual at once secured a fresh range of pasture over the same ground as their shorter-necked companions, and on the first scarcity of food were thereby enabled to outlive them. Even the peculiar colors of many animals, especially insects, so closely resembling the soil or the leaves or the trunks on which they habitually reside, are explained on the same principle. For though in the course of ages varieties of many tints may have occurred, yet those races having colors best adapted to concealment from their enemies would inevitably survive the longest. We have also here an acting cause to account for that balance so often observed in nature, a deficiency in one set of organs always being compensated by an increased development of some others, powerful wings accompanying weak feet, or great velocity making up for the absence of defensive weapons. For it has been shown that all varieties in which an unbalanced deficiency occurred could not long continue their existence. The action of this principle is exactly like that of the centrifugal governor of the steam engine, which checks and corrects any irregularities almost before they become evident. That image of the steam governor is a powerful one, which I can't help feeling Darwin might have envied. Historians of science have raised the suggestion that Wallace's version of natural selection was not quite so Darwinian as Darwin himself believed. Wallace persistently used the word variety as the level of entity at which natural selection acts. There was an example there in the quotation I just read, and also in Wallace's usage of the word race in a similar sense. And some have suggested that Wallace, unlike Darwin, who clearly saw selection as choosing among individuals, was proposing what nearly all modern theorists rightly denigrate as group selection. This would be true if by varieties or races Wallace meant geographically separated groups of individuals, or races in the more usual sense of the word. And at first I wondered myself whether Wallace meant that, but a careful reading rules it out. By variety and race, Wallace clearly meant what we would nowadays call genetic type, even what a modern population geneticist might mean by an allele. To Wallace, in this paper, variety meant not a local race of eagles, for example, but that set of individual eagles whose talons were hereditarily sharper than usual. If I'm right, it's a similar misunderstanding to the one suffered by Darwin, whose use of the word race in the subtitle of The Origin of Species is sometimes misread as supporting group selection or even racism. That subtitle, actually alternative title, is The Preservation of Favored Races in the Struggle for Life. Once again, Darwin was using race to mean that set of individuals who share a particular hereditary characteristic, such as sharp talons, not a geographically distinct race such as the hooded crow. If he had meant that, Darwin too would have been guilty of the group selection confusion. I believe that neither Darwin nor Wallace was, and by the same token, I don't believe that Wallace's conception of natural selection was in any particular different from Darwin's. As for the calumny that Darwin plagiarized Wallace, that's rubbish. The evidence is very clear that Darwin did think of natural selection long before Wallace, although he didn't publish it. Why he delayed so long before publishing it is one of the great mysteries in the history of science. Some historians have suggested that he was afraid of the religious implications, others the political ones. Perhaps he was afraid of upsetting his devout wife. Maybe he was just a perfectionist, keen to have all his evidence lined up and in place before going public. Or did he just get distracted by barnacles? When Wallace's letter arrived, Darwin was more surprised than we today might think he had any right to be. He wrote to Lyell, "I never saw a more striking coincidence. If Wallace had had my manuscript sketch written out in 1842, he could not have made a better short abstract of it. Even his terms now stand as heads of my chapters." The coincidence extended to both Darwin and Wallace being inspired by Thomas Malthus on population. Darwin, by his own account, was immediately struck by Malthus's emphasis on overpopulation and competition. He wrote in his autobiography, "In October 1838, that is 15 months after I had begun my systematic inquiry, I happened to read for amusement Malthus on population, and being well prepared to appreciate the struggle for existence which everywhere goes on from long continuous observation of the habits of animals and plants, it at once struck me that under these circumstances, favorable variations would tend to be preserved and unfavorable ones to be destroyed. The result of this would be the formation of new species. Here, then, I had at last got a theory by which to work." Wallace's epiphany after reading Malthus took longer to happen, but was more dramatic when it came to his overheated brain in the midst of a malarial fever on the island of Ternate in the Moluccas archipelago. "I was suffering from a sharp attack of intermittent fever, and every day during the cold and succeeding hot fits had to lie down for several hours, during which time I had nothing to do but to think over any subjects then particularly interesting to me. One day, something brought to my recollection Malthus's Principles of Population. I thought of his clear exposition of the positive checks to increase, disease, accidents, war, and famine, which keep down the population of savage races to so much lower an average than that of more civilized peoples. It then occurred to me," and Wallace proceeds to his own admirably clear exposition of natural selection as the guiding principle of all evolution. I want to recognize a succession of bridges to evolutionary understanding, specifically natural selection. And I can conveniently illustrate the first 4 bridges with our 4 claimants to independent discovery of natural selection. Blythe crossed the first of Darwin's 4 bridges, Matthew the first 2, Wallace the first 3, and Darwin all 4. The first bridge is to natural selection as a force for weeding out the unfit. I've used Blythe as my example of a 19th century writer who crossed this bridge, but really the only reason to single him out is that he's been championed by Laura and Isley as a predecessor, even a possible source of Darwin's ideas. As Stephen Gould has argued, however, the idea of natural selection as a weeder out, a purely negative force, was already widespread. Gould even quotes William Paley himself as setting out this purely negative version of natural selection. And as I remarked before, it's almost an anti-evolution argument, for it uses natural selection to explain the fixity of species rather than their changing into other species. Darwin's second bridge is the recognition that natural selection can drive evolutionary change, and it, in modern jargon, amounts to the difference between stabilizing selection and directional selection. Matthew, Wallace, and Darwin all crossed this second bridge. Bridge number 3 leads to the imaginative grasp of the importance of natural selection in explaining all of life in all its speciose richness, and especially to dispel the illusion of design. Wallace and Darwin clearly crossed bridge number 3. Maybe Matthew did too, but I've given reasons for doubting that he developed the full imaginative vision of the constructive power of Darwinism, as Wallace, in a generous gesture, was later to dub it. Bridge number 4 is the bridge to public understanding and appreciation. Darwin crossed it alone in 1859 by writing The Origin of Species. It's a striking fact, remarked by Darwin himself, among others, that when the Darwin-Wallace papers were read to the Linnean Society in 1858, nobody took a blind bit of notice. even among the professional biologists in that august body. The famous end-of-year clangor of the hapless president of the Linnean Society, Thomas Bell, has rung on down the ages. In his review of the Society's transactions during 1858, Bell said that the year had not been marked by any of those striking discoveries which at once revolutionized the Department of Science on which they bear. The end of 1859 would have to be reviewed very differently. The origin of species struck the Victorian solar plexus like a steam hammer. The world of the mind would never be the same again, neither science nor anthropology, psychology, sociology, even, and here we come close to the dark side, politics. This book, which Darwin always described as the abstract of the great book that he intended to write but never completed, achieved what the 1858 papers did not. It isn't just that the origin explained the theory more clearly than Darwin's and indeed Wallace's brief offerings of 1858. The real difference was that a book-length treatment was required to muster all the evidence and lay it out for all to see, one long argument, as Darwin himself called it. And I quoted before Darwin's own recognition when the joint papers of 1858 fell flat that this shows how necessary it is that any new view should be explained at considerable length in order to arouse public attention. And is there a fifth bridge which Darwin himself never crossed? Inevitably, 150 years later, there are several, but the one I shall single out is the bridge to the so-called neo-Darwinism of the modern synthesis. I shall rename neo-Darwinism digital Darwinism. There may be other things more neo than the neo-Darwinian modern synthesis of the 1930s, but digital Darwinism is here to stay. The essence of Mendelian genetics is that it is digital. Mendelian genes are all or none. They don't blend. Genes are things you can count in a population's gene pool. Evolution consists of changing frequencies of discrete, digital, countable entities, not changing quantities of substances or changing measurements of dimensions. Changing quantities and measurements apply at the organism level, but not at the gene level. What happens in natural selection is that successful genes become more frequent in the gene pool and unsuccessful genes less frequent. Frequent as in counted. Darwin never crossed the digital bridge. If he had, he would have had a ready answer to Fleming Jenkin, the Scottish engineer who, independently of his colleague Lord Kelvin, his colleague he collaborated on laying the transatlantic cable, gave Darwin a hard time over matters of theory. As is now well known, Jenkin pointed out that if inheritance were blending, as everybody except Mendel assumed, natural selection couldn't work because there wouldn't be enough variation. As a matter of fact, any fool could have seen that Jenkin's premise must be wrong. Variation clearly does not dissolve away as the generations go by. If it did, we'd all be more similar to each other than our grandparents were. R.A. Fisher, J.B.S. Haldane, and Sewell Wright buried Fleming Jenkin. If genes are countable digital entities that don't blend, their frequencies have no inherent tendency to change. If they do change, that's evolution, and it happens for a reason. The most interesting reason is non-random selection, but random drift also occurs. In the light of the Watson-Crick revolution, we can now see that the very genes themselves, within themselves, as digitally coded messages, are digital in exactly the same sense as Mendel saw with respect to whole genes. Of the three founding fathers of population genetics, it was Fisher who, in his great book of 1930, most clearly expressed the evolutionary significance of blending inheritance and its Mendelian antithesis. If genes did indeed blend, then the variance would be halved in every generation. But, of course, given that inheritance is digital, that wouldn't happen. Fisher quotes at the beginning of his book a letter from Darwin to Huxley, tentatively dated 1857, before the origin, which shows how tantalizingly close Darwin himself came to Mendelism. I have lately been inclined to speculate, very crudely and indistinctly, that propagation by true fertilization will turn out to be a sort of mixture and not true fusion of two distinct individuals, or rather of innumerable individuals, as each parent has its parents and ancestors. I can understand on no other view the way in which crossed forms go back to so large an extent to ancestral forms. But all this, of course, is infinitely crude. Even Fisher didn't know how breathtakingly near Darwin really was to discovering Mendelian genetics, even working on sweet peas. In 1867, he wrote a letter to Wallace that began as follows: "My dear Wallace, I do not think you understand what I mean by the non-blending of certain varieties. It does not refer to fertility, an instance will explain. I cross the painted lady and purple sweet peas, which are very different colored varieties, and got, even out of the same pod, both varieties, perfect, but none intermediate. Something of this kind, I should think, must occur at first with your butterflies, though these cases are in appearance so wonderful. I do not know that they are really more so than every female in the world producing distinct male and female offspring." That last sentence is a beautiful example of the power of reason and the importance of seeing through the obvious. When a male mates with a female, you don't get a hermaphrodite. You either get a male or a female with approximately equal probability. In a way, Mendel never needed to go into his monastery garden. All he had to do was take the inheritance of sex itself and generalize it to all other cases of inheritance. Digital heredity was staring us in the face in the most obvious way you could imagine. The trouble was, it was too obvious to be noticed. Darwin kind of noticed it, and he came close to making the connection. Well, Darwin did notice it. But just as Patrick Matthew didn't quite cross the bridge that Darwin and Wallace crossed, so Darwin didn't quite manage to cross the Mendel-Fisher bridge, at least not decisively enough to answer Fleming-Jenkin. I distinguish bridge 1 from bridge 2 as stabilizing versus directional selection, but there's more to it than that. I'm talking about the distinction between selection as a negative force and selection as a positive, constructive force that puts together complex new, quote, designs. My own preferred way, the selfish gene way of explaining this, is again to deploy digital genes. So perhaps we really have to cross bridge 5 in order to paint the full picture. In modern genetic terms, not Darwin's own, natural selection may be defined as the non-random survival of randomly varying coded instructions for how to survive. We see and admire the products, the phenotypes of the good ones. The instructions are DNA, and the most visible products are bodies that survive by doing something impressive, flying, swimming, running, digging, or climbing, all in the service of reproduction, which means they also tend to be good at attracting a mate and warding off rivals. An important part of the environment that each gene must exploit, if it's to ensure its survival in the form of copies of itself, is the other genes it encounters in the genomes of a succession of bodies, which, because of sexual reproduction, means the other genes in the gene pool of the species. As a result, cartels of mutually supportive genes cooperate to build bodies that specialize in some particular method of surviving, such as grazing or hunting. Different cartels are the gene pools of different species, bound together by the remarkable phenomenon of sexual recombination, and separated from all other cartels, for it's part of the definition of species that they can't interbreed. Occasionally, often through accidents of geography, gene pools find themselves subdivided for long enough to become sexually incompatible, and the subdivisions are then free to go their separate evolutionary ways as distinct species. Eventually, separate ways can mean very separate indeed, for animals as different as vertebrates and mollusks originally split apart as members of the same one species. Successive branchings of this kind have given rise to hundreds of millions of species over thousands of millions of years. At least in sexually reproducing species, evolution consists of changes in gene frequencies in gene pools. Each individual genome is like a shuffled pack of cards. The available cards to be shuffled are sampled from the gene pool. The species gene pool is a database which becomes a storehouse of information about the environments of the past, environments in which ancestors survived and passed on the genes that helped them to do so. To the extent that present and future environments resemble those of the past, and mostly they do, this genetic book of the dead will turn out to be a useful manual for survival in the present and future. The repository of that information will at any one moment reside in individual bodies, but in the longer term, where reproduction is sexual and DNA is shuffled from body to body, the database of survival instructions will be the gene pool of a species. Each individual's genome in any one generation will be a sample from the species database. Different species will have different databases because of their different ancestral worlds. Like sand bluffs carved into fantastic shapes by the desert winds, the database in the gene pool of camels will encode information about deserts and how to survive in them. The DNA in mole gene pools will contain instructions and hints for survival in dark, moist soil. The DNA in predator gene pools will increasingly contain information about prey animals, their evasive tricks, and how to outsmart them. The DNA in prey gene pools will come to contain information about predators and how to dodge and outrun them. The DNA in all gene pools contains information about parasites and how to resist their pernicious invasions. Natural selection carves and whittles gene pools into shape, working away through geological time. It's an image that might have seemed strange to Darwin, but I think he would have come to love it. Thank you very much.